Welcome to this mobile community, mobile people community day 2. We will talk about iOS Apple today, and I will show you the t-shirt from WWDC 19. Do you remember when the conferences was offline? Today, the most conferences are online, and we will prepare online digital presence for you. My name is Vsevolod Ben, and I will moderate and keep timing of today's session, today's talks. Today, we will have 5 sections. We will start with talk about architecture. We will know about what is UDF architecture and Redux. Then we will talk about a panel discussion about app rating. And our experts will share all they have, do their best about this topic. Then we will go to a topic about how to find a user's location. We'll talk about image recognition, GPS, Bluetooth beacons. Then fourth section will be special computing and WWDC 23 announcement, including this Apple Vision. And the last section will be a quiz where the best 3 of you will have digital prizes from our community. I want to notice this session will be recorded, so you can take a look at the record after, or you will share with your friend. But I encourage you to ask questions in the YouTube chat. We will find all of the most interesting questions and we'll ask them after each talk. And if you see this in recording, you can ask your question in the comments below. Also, we have guys who are watching us from VR community platform, and you can ask your questions in the chat and the QA section. We will also ask all the questions to our speakers today. Be active. It's your chance. It's a conference for you, so you can ask everything you want to your career development, everything. And everything you can check at the agenda. And let's talk about our first speaker. Our first speaker is Nikita. He will talk about UDF, unidirectional data flow architecture, if I understand correctly, and Redux. About Nikita, as he mentioned about himself, that he's open-minded, hardworking, and result-oriented developer. Our DNA. He made iPhone 2D games. He have a huge amount of engineering experience. He have information. He have made some apps with the government meetings service, and he's also baccalaureate in the computer science and cybernetics. Hello, Nikita.
Yep. I've said a lot. Can you hear me?
Yes, we hear you perfectly. You are the first speaker on today's session. Are you worried about being first?
Oh, a little bit, to be honest, but I think everything will be fine. So we can dive into our talk, and I think that everything will be fine and okay.
Sounds good. The stage is yours. Please, guys, welcome Nikita. We are here.
Yep.
Ask your questions.
Hi, everyone. Welcome to my talk. We're going to talk about unidirectional data flow architecture and Redux. So, yep, without further interruption, let's dive into our slides. Here's our agenda. First of all, we're going to briefly talk about the UDF architecture and Redux theory, and it would take, I don't know, very short amount of time because I know that nobody likes the role theory and everyone wants to practice. So the majority of the presentation will be the application example that is written using the Redux architecture. So a lot of code. but I think that we will get used to it. Yep. So let's start. First of all, as I know, uh, the first who came up with this data flow, unidirectional data flow, were Facebook. They had a serious bug on their web application where they had a lot of different models on the screen, and on these models you can see how many unread messages you had. So, for example, on one screen you can three different parts of the screen were indicating how many unread messages there are, and they could show different results. So one of them shows 100 messages, another one 10, and the third one shows that all the messages are read. That was because of the models were independent, and it was really hard to update and to synchronize all of them. And Facebook, with their enormous account of their engineers, couldn't do anything just to came up with a new solution, the unidirectional data flow. The main idea of that one that all the data comes in the circle in one direction. So when something happens in the UI, the UI doesn't try to handle this in any case. It updates itself with some input data and display this data. And if something needs to be changed, the UI sends some action to the state, AppState, that contains all the information about the app. There's some magic happening, and the new data will be transferred to the UI as a new input data, and UI will update itself. Yep. So here is more. Yep. Sorry. Here is more detailed diagram of that one. So as we saw on the previous state and the previous slide, here is our state. It is application state, the state of all of the app. It contains all the necessary info for the UI, so it held there. The second one is the action that the UI will set these actions. It is the list of all the events in the application. Yep. So the new one, our new hero, is the reducer. It is the pure function that is responsible for updating the state. So the action will come to the reducer, and the reducer will update the state. As you can see here, this is the semantics of this reducer function. It takes this action that was sent and the previous state of the application, and after the modification, it returns the new state. The store, it is main part of the architecture. It stores the state, it stores the reducer, and it's also responsible for subscribing and notifying the UI after the update. So everything is happening is like something happens on the UI. The UI sends the action to the store. Store calls the reducer with the parameters of this action and the current state. Reducer updates the state, and the store notifies the UI with the new state, and the UI updates itself. In the Redux, it is a little bit more complex. When I first saw it, I was like Gomer Simpson like that, so don't be worried. I think that we'll come up with it later here. So the new, first and foremost, that the store is global and the only one for their entire application. So it comes with a single source of truth of the application, and everyone are referring to it. The second thing is the new middlewares. There can be as many of them as you want. They're passing an array to the store when the store creating, and they will fire one by one. They're responsible for asynchronous event, communicating with different services like network service, etc. And the action will go in the middleware 1 to the middleware n before going to the reducer. And here is a little bit extension of the UI layer. It is just it is not a part of the Redux. It is the part of the data-driven UI. Yep. And I've added a new layer of presenter, and the idea is to make the view super dumb, if we can say so. The presenter takes the state and transfers the state to some props, and the view is referring to props. So the view doesn't decide what to take from the state. In props he has something like, I don't know, title, subtitle, some actions, login action, etc. So it gets a great testability, and yep, we will take a look at the action. Yep. So in this diagram, we can see that when something happens, the action is sent to the middle. The action is sent to the store. It comes to the first middleware, to the second, third, etc. After that, it comes to the reducer. Reducer updates the state, and the store notifies the presenter that the state was updated. Presenter transfers state into the props, passes to the UI, and the UI updates itself with these new props. Yep. So as I said, it would be super briefly about the theory. So let's dive into the code and the application example. First of all, I want to show you this super simple application. Why I made this super simple? Just because we want to see the architecture and it is easier to understand on some simple stuff. Yep. So we have the first screen. It is just an empty screen with a plus in the navigation bar. If the user taps it, he will see the alert of entering some element. There is no validation, just not an empty one. So yeah, we will see it later. So the user enters something, some best element name, and press add button, and it adds to the list. And if the user taps on the element, he can dive into the details and see what is going on in the details. Yep, so super easy, and let's dive into our code. So let's start with the AppState. AppState is our application state. It is responsible for all the application. Here is nothing super interesting because AppState is just a combination of its children states. RoadState is a state for navigation, responsible for navigation. Item list state is the first screen state, and the item detail state is the second screen state. Note that item detail state is the optional one. This is because this is because there can be details and there can be not. So I've made it optional. And here is the reducer of the application. As you can see, it takes action, it takes the current state and returns the new state, updated one. So this reducer is just a combination of its children reducers. So it's nothing super interesting about it. Yep, the second one is the store. Our store here, I'm using ResVip library. We can come up with our own solution of the store because it's not so difficult to write that one, but I decided just to use the external library because it is well tested, and yeah, that's it. So we are creating the store. We are passing this generic parameter our AppState. And here we are creating the store with the AppState reducer. Initial state we don't need it. And we're passing middlewares as an array. Here I only created one middleware for the routing. We'll see it later. So this is how the store is created. The next one, we see actions. I've divided the application into the core layer and the UI layer. That's why we have two different action enums. The first one is will be accessible from the UI. The second one won't be accessible, just some helping actions, then will be triggered just inside the core layer. And here are the first screen actions. As you can see, you can make an enum, you can make a struct, no matter what. The main thing is just to inherit from the action protocol, and it will work fine. Yep, so we have two different actions. The first one is the add new item with some string item. And the second one is the move to details. Yep, that's all the actions we have on the first screen. Here is our item list state. The state of the first screen, it is super easy. We have the array of items that we will present in the table view, and we have a mutating function that will add the new items to the array. Nothing special. And here is the reducer of the item list state. It is more interesting. So first of all, if there is no state, we will create one, and then we start working with the actions. We're only working with item list actions. If it would be some other action, we will just break through the switch and return the current state that we already have. And here is we are working with the item list actions. On the add new item action, we will call the add item that we saw on the previous screen that will update the array. And on move to details, we won't do anything because we don't need to update item list state on the click on that cell. Yep, so we can see the halfway of our application here of the first screen. Yep, after user enters the new element and presses OK, the action add new item would be dispatched. It will come to the application AppState reducer, which will lead us to the item list state reducer. Here we will go to the action add new item as it was dispatched, and it will update our item list state with the new element. After that, the store will update the UI with the new item list state, and the UI will update itself. So yeah, let's dive into how the UI updates itself. Yep, as I said earlier, I created the presenter, the layer between the UI and the store that will convert the state into the props. It is the base protocol. Every presenter will inherit this protocol. It has three different things. The first one is the props. Each presenter will decide which props does he want, so it would be a struct with some fields. The second function is just for converting application state into the props. So when the state will be updated, the store will notify the presenter with the app state, and the state and the presenter will be responsible for updating app state to the props. So this function will be overridden and in the presenter, and the third function, it is made here. It is for converting subscription of the app state to the subscription of the props. It is done because the UI will automatically get the update of the props when the app state will be updated. So yeah, we can see that we're using the REST function select on the subscription, which will convert subscription from app state to the props with the help of our function present that will be overwritten later. And this one is just for where props are equatable, so we will skip repeats if we will receive the same array as we did already, so we won't update the UI if it is not needed. Yep. So here is the base store view controller. It will be also inherited from the all view controllers. As you can see, we have the generic parameter of the presenter here, and we are subscribing to the store in the view controller. So in the view will appear, we will subscribe to the store with the transformation of the subscription with this function present that we had in the previous screen. So we will receive in this function, REST function, not the state, we will receive props. And we will call the function render props, which this function will be overridden in every view controller, so it will get the correct props here, and we'll work with them. And then view will disappear. We're just unsubscribing of the store, so we don't need to update the screen if it is not visible. It doesn't make any sense. And here is the presenter of the first screen. Here are the props. We are creating the props struct. It has two values. The first one is an array of cells, just to display everything, and the second one is the closure of the add button pressed action. It is for the plus button handling that is in the navigation bar. we can see that the cell struct is super easy. Also, it has just a title to show to the user and the selection action, which which we will fire when the user taps on the cell. And here is the function of the recreating AppState to the props. So we take the item list state items and map them to the cell with the title of this item, and the selection action we will call the action move to details with the same item. And we will return the props with the cells that we created. And also we have this add button pressed action. It will be the new action, alert action, show alert of this type. Yep, so just to show the new alert, and the next magic will be there. We'll see it soon. Here is our item list view controller. It is nothing special, super easy. We also inherit from the store view controller with our presenter that we showed earlier. We are defining the props here. We are creating the UI bar button in the navigation bar. And here is selector of the bar button, and it will call the function from the props. On the AppState update, it will render. It will render to the props, and we will receive the props here. So we will resave the props and just reload the table view so we can see the updated UI. And here are just the basic delegate and data source of table view protocols. Number of rows just from the props cells count, and cell for item we just get in the cell title from the props, and then did select row we are just get the selection action from the cells from the props that we have already. And we're here with the full cycle of the first app. A little bit not, but it is a spoiler. So the user presses on the plus button, it gets us to this selector. It called the props add button press action. In the presenter, we defined that this action would fire an alert or fire an action that will show us the alert of this type. This is plus type handling. It is just the alert logic. There are some extra magic happening there. We will see it in a couple of slides. In the end, we will, if everything is okay, the new action will be dispatched, add new item with some text that the user entered here. And as we saw in the previous half cycle, this one will update the item list state, so the app state will be updated. So after the app state updation, our presenter will receive the new state. It will convert everything to the props, and the props will be given to the UI. They will be received, and the table view will be updated. So we will see the updated UI. So let's dive into how we can move to details right now. Here are our actions. As you remember, we have the second action, move to details, in the item list action. And here are actions of the item details. We have two actions. The first one, exit details, when we will exit the details just to delete it. And the second one, the select, just to create it. We will see it in the next slide. Here is item details state. As you remember, it is a part of the app state, and it is optional because there can be state and can be not. And here is this app state. It is super easy, just one item it has in itself, and that's it. And here is its reducer. It takes only two actions, item details actions. On the select action, we will create the item details state with this name. On the exit, we will just kill it and destroy. All other actions will be ignored, and we will return current state that it has right now. As you remember, we are dispatching the event move to details from the item list action from the first screen on the cell selection. Here is the tricky part, because in my opinion, in every architecture, this navigation is a little bit tricky. So I saw there are a lot of external libraries that are responsible for the navigation, but I just didn't want to use them. I tried to come up with my own So here it is what we have right now. It is not perfect, but it works. Just for this small application, it is fine. Yeah, so here we have the enum of the road and destination. It is just the list of the screens that we have right now. It is also would be better to use some external library for the code generation, just to come up through all your screens, yeah, and get their names. But I just didn't want to add it to the simple project as well, and so that would be easier to add two cases to the enum, and that's it. And here is the action of the here we're extending the action, the new routing action that will take the destination from here. So where we should navigate to this view or to the second one. Here is the routing state, which is a part of the add state. Either it takes the navigation state, this destination that we had on the previous screen, one of two screens, and the alert state, which is responsible for showing or hiding the alert. It is also optional, because there can be alert and there can be not. And here is its reducer. So we create the routing state if there is no one. And if it is a routing action, we will update the navigation state of on what screen we're going to move. And if it is the alert action, we will update the alert state with its own reducer. And this superhero is responsible for all our navigation in the application. It is super easy. It just has the window of application, navigation controller, our main controller, and the alert provider is the helping class for providing us the correct alert of the type of the enum. Yep, we will show it in a couple of slides, so don't be worried about it. In our init, we just create the navigation controller, create the alert provider, and set in the navigation controller. Nothing special. Interesting part is this store subscription. So we are subscribing to the store update, but also we are, as you remember, as we did in the presenter, we are updating the subscription just to receive the routing state. So we are ignoring all other states, and as you can see on the next one, so we are receiving only routing state. Other one are not interested in the app coordinator, so that's it. Here we just call the push view controller with the with the screen that is currently in the navigation state, and also we're handling the alert state from this routing state. All the necessary checks, either it needs to be pushed or either it needs to be shown the alert, are in these functions. So we can play around and add more presentations, like model presentation or any other. Just I added the one so it would be easier and not to make any complex decisions. And here are our middleware, our hero new. From here, we're going to dispatch this routing items. It is obvious from the name that this routing middleware will be responsible for routing and navigation. So here we're creating this. First of all, I want to mention that middleware has two main functions. The first one is dispatch and the next one is next. The main difference of them is that dispatch, it will fire a new action. So any other action, it will fire from the beginning. So we have 5 middlewares. We are in the number 3. We will dispatch the new action. It will come back to the middleware 1, go all the cycle, and go to the router. And if we call the next, it will come to the next middleware if there it is one, and to the reducer. Yep. So we are handling item list actions and item details action in just two different functions. We will come to them in the next slide. And as you remember, we've passed middleware as an array when we created the store. Yep, here are the functions of the middleware. So here we are handling item list actions. When we want to move to details, we dispatch two different middleware dispatch two different actions. The first one is to select item details, so it will create item details state, and the second one is the route action that will update the app coordinator and say that we need to move to the item details, and it will push the new view controller. And as you can see, this move to details action, it will be killed in this point, so it won't come to the reducer. Add new item. On add new item, we will dispatch the first action is to close the alert. And the next one, it will pass this add new item to the reducer. So in this case, this action will go next to the reducer and move to details won't. And in item details actions handling, we are having that it's when we're exiting the screen, we will dispatch that route action to change it back to the item list screen so we can move back, and just push this exit details to move on, so we will delete the item details state. So here is our flow. Yep, first of all, the user selects the row, and it will dispatch the action move to details with some item. We will come to the route in middleware, where we will dispatch two different actions. The first one is select, where we will create the item details action here, and another one is the route action that we will move to the details. It will update the routing state with the new destination, and it will update the app coordinator. It will notify the app coordinator that the routing state was updated, and we will push the new view controller with this destination. So that's how we will show the new screen. And here is the presenter of the new screen. It is also the second screen is super easy. It's just in the props we just have the title to show and the move back completion. On the title, we'll take the item details state item from the state, and on the move back completion, we will dispatch the new action just to exit the item details. So it would be killed. And here is item details view controller. As you can see, it is also inherited from the store view controller with our presenter that we created on the previous slide. We have our props from our presenter, and on the props update, we will update the item title, our UI label with the title from the props. On the props update, we'll just resave the props, and on the view will disappear. We are checking that we are moving back and not forward. So if we're going back, we will just call the move back completion from the props, so we can destroy the item detail state, and it won't be necessary for us anymore. And the last thing that we didn't handle right now is here it is the alert, our alert. Here are alert actions. I created the enum of all our alerts in the application, so here we have only one, add new item to the list. And in the alert actions, we have two different actions. One is to close alert, so delete it, and the second one is the show alert of some type, which is here. And here is our alert state. As you remember, it is the part of the routing state. It is also optional because there can be alert and can be not. And the alert state is super easy. We just have the current alert to show this application alert. It's just our with one case for this app. And in the alerts reducer, we are handling alert actions. And on the show alert actions, we just create the alert state with the state of the current alert, with the type of the current alert, right? And on the action alert closed, we will just destroy it and return nil. All other actions will be ignored. Sorry. Yep, all other actions will be ignored and won't affect alert state in any case. Yep, as you remember, we are handling alert state in app coordinator as well. Here it is this function, we are calling it on the updation of the route in state. And here is the function. So we are checking that there is alert state. We have something to show. If there is, we're checking that the current view controller isn't the alert controller, so we won't show the alert if there is alert. Yep, just like that. And we will create the alert with the alert provider. It is just a helping class that gives us the correct alert for the current type. And the top view controller will show the current alert. Yep, the alert that we created. And here is how we create the alert. It is just the basic UI alert with two actions. The first action is OK action. We have the text field there. So as I said, we have super easy validation just for it is not empty. If it is empty, we just will close the alert and nothing will happen. And if there is a text, so we will dispatch the add new item and the list will be updated. Also, we have the cancel action for the cancel button. All of them will just dispatch the close alert. And as you can see, if it is the success, we are not closing the alert. We're closing it in the middleware. Yep, there in the add new item, we dispatch the alert close, and also we pass this action to move on. We can dispatch here another action as well, so we can delete this one and dispatch here alert closed. I did it just because I wanted to show you how the middleware works, so that you can dispatch one element and pass the next one there. So yeah, so this one is not necessary at all, and it would be even better to close alert here, just do not forget to close it in other places. And yeah, we're done with everything, and here is our full application flow. So the user gets to the application, he taps on the plus button in the navigation bar, it dispatches the show alert action, which calls the alert state reducer. It updates the alert state, and after this update, it updates routing state. App coordinator will show alert view. Here we have two different scenarios. We can just close the alert, so it will go to this cycle and just to destroy the alert state, and the app coordinator will close the alert view. And the next one, if we enter something and the user presses OK, so we will dispatch add new item. We will come to the routing middleware. As you remember, we have dispatch close action alert there. It will close the alert and also pass this next create new item action next. It will come to the item list reducer. It will update the item list state. So it will update the app state. So it will update the app state. The presenter of the first screen will get the notification that the app state was updated. It will convert the app state to the props, and the UI will update itself. And when the user will tap on the role, we will dispatch the move to details action. We will also come to the role in middleware, and there are two different actions will be dispatched. The one for the creation of the item details state, it will come to the item detail state reducer. It will create the item detail state. And the second one is the routing action that will come to the routing state reducer, update routing state, come to the app coordinator, and it will push our new view controller. Yep, so that's how it works. Hope it was a little bit interesting for you. So thank you. If you have any questions, I'm here to answer them and ready to answer.
Thank you, Nikita. We appreciate your slides. You made a great deal. And also, will the slides be available? Also, Eduardo Rodriguez asks the question, is that example code will be available somewhere?
Yep, sure. It is now in the GitLab or GitHub. I don't know. I don't remember exactly. I have a link, so I can post it somewhere, so it can help me with that one.
Okay, I think we can post it under the comments on the YouTube channel, and it will appear after this session, if it's okay for Nikita to share after this talk.
Sure. Also, the initial presentation was made side by side with the Android application. The other guy made the same application for the Android, so I can share the second link either, so you can take a look if there are some Android guys on this iOS presentation. So yeah, I can share that one either.
Perfect. We have one more question from Dmitry Sulzhenko. We have this start. Hi there. Do you have a store with reducer as a single source of truth? Or it can be shifted to more down in app architecture and let the service have it? And he brings the example with the next comment. For example, imagine we have an app, feature 1 and feature 2. They're different for both, has some logic that works with authorization state. And will the app reducer hold shared state between feature 1 and feature 2 and pass them it into them? Or feature 1 and feature 2 will use authorization service and the service will hold actual source of truth. Do you understand the question?
Not really. Can you repeat the first part? Not the example,
Mhm.
and just the first part.
Yeah. This is the question is on the screen. Also, do you have a straw with a reducer as a single source of truth? Or it could be shifted to more down in app architecture and let the service have it.
Mm-hmm. As I get it correctly, in the example, Dmitry said that we have the feature 1 and feature 2, which are communicating with the service, some authorization service or something like that, and they are both communicating with this service. And his idea is that the single source of truth is shifted to this authorization service and not to the AppState. If I'm right, so in my opinion, yep. So when we are communicating with external services, as I said, we're using the middleware. So when the action will be dispatched, we will come to some, I don't know, session middleware. It will get the backend response to get some token. We will store this token to the, I don't know, some session state or something like that. And when the user will make some other authorization calls or something, any other calls, so we will use the token from the session state that will be kept in the app state. So the main goal is to keep this app state the single source of truth and to keep any logic, not logic, any information that we need there. So using the external services is good. It is super great, but the result of them must be saved to some child state of the app state and used there. So something like that.
Good. let's take a look at one more question from Dmitry Kazanovsky. And Dmitry Kazanovsky asking on the VR community, which approach shows better performance? This one or Swift UI in the brackets MVVM? It looks similar. Also, he said that looks more complicated than Swift UI.
I don't think that Swift UI MVVM is something like the Redux itself, because we can use the Redux with the Swift UI as well. As about the speed, as I look at some different videos and other lectures, the guy, I don't remember his name, he told about his project that they had some video chat or something like that, and the state updated like some frames updated in a second, like 24 frames per second or something like that. So that's how many times updated the state, and the app worked perfectly fine. So I don't think that there would be some problems with the speed and optimization. And I also had some small project with implementing the Swift UI with the Redux, so it works totally fine with that as well. The difference is just I don't know, like between the normal MVVM and the Redux that we have here, the single source of truth, and we receive a great testability of the unit tests and the UI tests. Yep. So.
Do I understand correctly also that in the frames per second, there is no difference between Swift UI implementation with MVVM and Redux implementation?
Maybe you're right. Yep, but for every application there should be different variants for the architecture. So if it is a super easy architecture, then we don't need to use the Redux just because it is a huge and not so simple as the MVVM. But the main power of Redux is just because the asynchronous update of the screens. So if some element was modified on the one screen, it will update all the screens, and when we go back, we don't need to worry about anything updating, and that's it. So that is the main goal.
Perfect. Thank you, Nikita. This we have I think, time for one more question. The question is, can we still make some simple actions from UI, like push new screens or any additional simple logic?
Yep, I get the question, because it is super easier to make some one-liner functions just from the UI and not to create some actions and the new states or reducers and something like that. So not to create the full flow and just to call one-liner. But in that case, we're destroying the unidirectional data flow perspective. So the UI becomes responsible for some events, and it is not the correct one, because the UI only needs to send the actions and not responsible for updating anything or any logic. So no, it wouldn't be the correct approach. And I understand your desire to make it easier, but in that case, it can, I don't know how to say, it can give us more errors and problems that you will save your time. So yep, that's it.
That makes sense. And what would you recommend for maybe new joiners or some developers who works with MVVM? Just give it a try for this architecture for the past projects from from business point of view.
Why not? It is just makes you a little bit wider as a developer, so you will know do you like it more or do you like it less? So you can't tell whether you like this approach or not if you didn't try it. So maybe you'll try and say, wow, how did I live my life without this one? Or just say, why do people use it? It's so awful. So you always have to try it yourself just to clarify for yourself, do you need it or not? So I don't see anything bad in just trying it and give it a try.
Good words. I think the kind of conferences like this is to try something new, to learn something new. And this sounds inspiring. Thank you, Nikita, a lot.
Yep. Thanks a lot. Thank you guys for listening to me. Yep. Hope you like it.
We liked it a lot. I like it personally. Right now, we have a schedule for 10 minutes break. I hope who will join us soon later. We will. I just want to remind you that we can talk to our speakers, and this is a great opportunity to talk with the high-level engineers, and just like we do it offline with a glass of water. 10 minutes break, and then we will talk about spatial audio. We will talk about how to find a user, geolocation. See you. Thank you.